In the clip presented today on my YouTube channel, I will talk about how to choose a water pump. Stay like this, but stay with me in the next few minutes to be up to date. Alexandru wishes you a pleasant viewing. The water pump is a piece of equipment used to transport water from wells, lakes, wells for the purpose of supplying various consumers. From a constructive point of view, the pump has three main components: the motor, the pumping unit, and the casing. Depending on the positioning, the pumps can be surface pumps. They draw, absorb liquid from a well, reservoir and push it to the consumer. They allow easy and quick access for installation and maintenance, but they present the following disadvantages. Requires additional frost protection. It consumes additional energy because the water must first be absorbed from the well into the pump body, and then pumped by the turbine to the place of consumption. Submersible pumps. They are completely lowered below the surface of the water, immersed in the liquid, which they push, return to the consumer. As such, they have the following advantages. Being installed below the frost limit, they are implicitly protected from the danger of breakage due to the freezing of the water in the pump body. They do not need priming. Being immersed, the water enters the pump body, which only pushes the water towards the consumer. There is no more absorption, so they are more efficient. Much reduced noise compared to surface pumps. Depending on the destination, water pumps can be for clean water. It is used for the transport of clean water and other liquids whose physico-chemical properties are similar to those of water, and is used for the circulation of hot and cold water under pressure, such as the supply and drainage of industrial and urban water, pressurized water supply in tall buildings, irrigation of gardens, heating and ventilation of the refrigeration cycle, firm irrigation, as well as used together with other equipment. For sewage, dirty water, it is intended for the transport of waste and residual water containing fibrous dirt, sludge and solid particles of a certain size. For chemicals, in general, it is used for the transfer and circulation of corrosive chemical liquid, and is applicable in industry, research institutes and laboratories, etc. 2. Principle of operation. The water is absorbed through the nozzle or suction slots, and pushed with the help of the pumping group, turbine, to the consumer. 3. The main characteristics of a pump. For surface pumps, maximum suction depth, maximum discharge height. For submersible pumps, the maximum discharge height, given the fact that they work only when they are immersed in the fluid to be pumped. 4. How do we choose a surface pump? We need to know the suction depth as precisely as possible. For suction from a maximum of 8-9 meters, a surface centrifugal pump can be chosen. If the pumping depth is greater than 8-9 meters, we will choose a surface pump with an ejector. We have to consider the supply route to consumers, both horizontally and vertically. In principle, to pump water 10 meters vertically, 10 meters water column height, we theoretically need 1 bar pressure. Thus, if the technical data sheet of the pump mentions that it has a maximum discharge height of 50 meters, this means that the pump develops a maximum pressure of 5 bars. Caution: the water flow at this maximum height will be practically zero. For pumping in a straight horizontal line, a pressure of at least 1 bar is required for every 100 meters of pumping. In conclusion, for raising water vertically, for every 10 meters a pressure of at least 1 bar is needed, and for pumping water horizontally, for every 100 meters a pressure of 1 bar is needed. When choosing a pump, we recommend consulting the pump's operation chart to calculate the required flow at the desired distance. 4. How do we choose a submersible pump? The pumping height, to how many meters we want the pump to raise the water column, and the water flow required at that height are taken into account. Attention: from the pump operating curve, the flow rate will be chosen depending on the pumping head. It is recommended to choose a pump somewhat more powerful than what results from the calculations, so that it does not have to work at maximum load. When you choose a water pump, make sure that it meets the requirements regarding the flow rate and discharge height and respects the economic principles, security and applicability depending on the use. 3. Lifting, pumping height. The energy that the water obtains through pumping determines the height of the water, head or lift. For a surface pump, the lifting height of the pump includes suction and discharge, is marked with H and is measured in meters. For a submersible pump, H is only the discharge height. The vertical distance from the pump turbine to the surface of the water source, the height of the water column that the pump absorbs, is called the suction height. In short suction, the vertical gap from the pump turbine to the consumer, the height of the water column that the pump discharges, is called discharge height. In short discharge, the lifting height of the water pump equals suction height plus discharge height. The discharge height of the water pump must be approximately 1.15–1.20 times the water lift height. For example, if the vertical distance from the surface of the water source to a water storage tank is 20 meters, then the necessary discharge height of the water pump should be approximately 23-24 meters. This must be taken into account because at the maximum discharge height, the flow rate is practically zero. The pump can no longer generate pressure because all the power is practically used to raise the water column to that height. It is not recommended to purchase a water pump with a very high discharge height. If a water pump with a high head is used, where there is a low head, the water flow will be too high and the engine will be overloaded. In the case of long-term operation, the engine temperature will increase and cause rapid wear of the engine parts.